Oh, hi there. We are a group of chemical engineering students from UCL, and today we should be talking about the importance and operation of P&IDs, non-return valves, and centrifugal pumps. Piping and instrumentation diagrams are used to outline a plant's operation by identifying the role of equipment showing all the interconnecting pipelines. They are important for all plants as they provide the main schematic of how plant processes are controlled to facilitate a smooth and safe operation. Here, we have a PNID for the production of benzene from toluene. This is the symbol used to represent a valve on a PNID, and there are many variations which represent different types of valves, such as a butterfly or a non-return valve. On the other hand, this is a representation used to depict a pump on this type of diagram. Finally, this symbol is used to indicate a compressor. Each of these equipment are crucial to the operation of large-scale plants. Such a plant is currently operating in the Middle East. Non-return valves come in many forms. They work by allowing flow in one direction but not the other. Fluid can flow only one way and any backflow will shut the valve. They cannot be directly opened or closed, but they are useful when implemented as a safety precaution for flow. Non-return valves are mainly used to protect pumps and compressors, so they have many applications in most industries, such as water treatment and petrol production. The construction of this non-return valve is very simple. As you can see, the valve stop is placed within the valve body with a spring used to keep the valve closed against any backflow in the pipe. A valve cover is securely fastened on top to prevent any fluid escaping from the valve. Non-return valves have two openings in their body, one for fluid to enter and another for fluid to leave. They work automatically, using a movable valve stop which creates an internal seal to prevent backflow. The valve stop can be either spring-loaded to keep it shut, or otherwise reverse flow is required to create the seal. Centrifugal pumps are perhaps the most common type of pump in operation today. With many different configurations available, centrifugal pumps are widely used because of their design simplicity, high efficiency, and wide range of capacity, allowing for the ease of operation and maintenance. They are widely used for the transport of lower viscosity fluids in industries such as food and beverages. Constructing the centrifugal pump begins by securing a cover to the back of the pump, followed by attaching the impeller to the front by securing it to the shaft. A small piece of metal called a feather key is fitted within the shaft and holds the impeller in place. The casing is attached around the impeller with the discharge nozzle facing upwards and at 90 degrees to the inlet flow. Centrifugal pumps use an impeller made up of curved vanes to transfer mechanical energy to pressure and kinetic energy in the liquid. The impeller is immersed in fluid, causing the fluid to rotate with it. Centrifugal force is applied to the water particles, causing them to move radially to the edge of the vanes, where they reach a higher pressure and are channeled out of the discharge nozzle. The pressure in the eye of the pump helps to suck the inlet flow into the system.